Okay, so in today's lesson, we're going to look at the laws of logarithms. And before we even look at the laws, what we're going to do is we're going to go over all the laws of indices that we've learned previously. Okay, so if we remember our laws, if we have two numbers that we multiply together that have the same basis, right? Right, so if we multiply, right, what we said we could do is we could just add the exponents, right? So if we multiply two numbers with the same base, we add the exponents. And in the same way, if we divide two numbers with the same bases, we could subtract the exponents. If we took a number that was raised to a power and we raise that to a further power, so if we raise it again by another power, we could multiply. Okay, and if you think about the reason behind exponential or exponents, it is to save on the multiplication. Okay, then we learned something about negative indices, right? All a negative indice meant is that we dropped the number either to the denominator, or if it was on the denominator and had a negative sign, we'd move it up to the numerator. So it's just a shift between the numerator and the denominator. Right, then we also learned that if we want to take a root of a number, right, we can write that as a power as 1 over the root. And combining the multiplication or the raising of the root and the squaring, we can see that we can write fractional exponents as well. So those were just our laws of indices that we learned back in IGCSE. Now we're going to touch on them because since logarithms are about exponents, some of the laws are going to be based off these indice laws. Okay, now just to preface, right? If we have an equation y equal to a to the x and we change that into index or to log equation, in other words, we make the exponent the subject, so we have log a y, right? We get these properties where log a, base a of a is equal to 1, right? In other words, what do I raise a to get a? And that's 1. What do I raise a to get 1? The answer is 0. If I have log base a to a, I can drop down to the exponent x. And similarly, if I have a base a to the power log with the same base, I can also simplify that into a value. Okay, now for logs to exist, both the base have to be positive, okay, and the value has to be positive. Okay, we don't deal with logs with negative bases or values. In the same sense, we also don't look at logs with base 1 because 1 doesn't follow the same rules as other numbers. Okay, let's look at our first law. Okay, this is the multiplication law that we're going to look at first. So maybe we want to consider something like log base 5 of 625. We could intuitively work out that this would be equal to 4 because we need to raise 5 to the power of 4 to get 625. In the same sense, we could also think about something like log base 5 of 5, or we could think about log base 5 of 125. Okay, and well, we know that a log with the same base and value is just equal to 1. And what do I raise 5 by to get 125? And the answer is 3. Now, what if I told you to add log 5 to 5 to log base 5 of 125? Okay, what I'm asking you to do is take 1 and add 3, and intuitively we could say the answer is 4. However, we can rewrite 4 since we know that log 5 625 is also equal to 4. All right, and what we're looking for here is there any kind of connection. And if we have a look at these two numbers, right, how do we get these two numbers to become this number here? And the simple thing is we multiply. All right, so the simple or the multiplication law of logarithm says that if we have log of some base of some value x, and we want to add that to log a same base of some value y, right, remembering that we are talking about exponents here, we can multiply the values. Okay, so just like if we go back to our laws of indices, okay, if we multiply exponents with the same base, we can add the exponents. If we add logs with the same base, we can multiply the values. Now, intuitively, we could do exactly the same for division. So we could take log 5 of 125 and log 5 of 5, and we could say, well, what's the value here? Well, log 5 of 125 is 3, and log 5 of 5 is 1, right? So if we had to subtract these, we would get 2, right? But another way of writing 2 is as log 5 of 25. And how did we get there? Well, here when we subtracted, we could divide the values of the logs. Right, so that brings us to our second law of logarithms. And again, it's based on the exponential law. So this time, if we subtract two logs with the same base, we can divide the values. Okay, so it's just a reverse of the exponent law. Okay, let's now look at the power law. Right, so the way we're going to do this is I'm going to say, what if we have log a of some value p, right? And I want to add this to log a of some value p, right? Now we can use the multiplication law that we just used, and we can say, well, this is just log a. When I add two logs that have the same base, I can multiply the value. So this would be p times p, which is just log of a to the, well, log base a of p squared. Okay, now this might not seem like we're getting anywhere. However, let's look at this again. Let's look at log a p plus log base a of p again. Right? When we learned algebra, right, we learned that if we have one of something and we add that to another of itself, because these are the same things, instead of writing this as two of the same thing, we could just simplify this and say we have 2 log a p, right? And because we haven't changed anything on the left and right hand side of the equation, that must mean this must be equal to log a of p squared. Now we can carry on. So what we can do on the left hand side is we can say, right, we have 2 log base a of p. Let's add another log base a of p. And on the other side, to keep the equation the same, we can add log base a of p here as well. Okay, now on the left hand side, I'm just going to simplify using algebra. So if I have 2 log of a base a of p and I add another one, then I will have 3 log base a of p. And on the other side, I'm going to say, well, using the laws of logarithms for the multiplication rule, if I add 2 logs with the same base, I can multiply the exponents, right? And p squared times p is going to give me p cubed, right? And hopefully you've intuitively seen what has happened here, right? So in each case, the exponent of the value, right, could just be moved down to the front. Right, so we could have just moved the p there, and in the same sense we can reverse that, and if we wanted to, we can move a number in front of a log up to an exponent of the value, right? And so that gives us the power rule for logarithms. So if we have log a x raised to some exponent m, this can be written as m log base a of x. In other words, we can bring the power of the value down to the front, or we can move the value in front of a log up as an exponent of the value. Okay. Now, one interesting rule that we actually get from the power rule, and also just using our logs, right, is if we have, for instance, let's say we had to find log a to 1 over x. Okay, what we can do is, using our index notation, is we can change this into log base a of x to the power of minus 1, because that's all it is. Now, using the power rule that we've just used or learned, we can bring this to the front, and so we get log base a of x. Okay, and so that brings us to another important log rule, is that if we have log base a of 1 over x, this is the same as minus log base a of x. Right, and those are the these are the 3 logarithm laws, and the other one is just a variation of the power rule. Okay, now using these, we can learn to solve and simplify logarithms, right, in equations and exponential equations, etc. So let's look at some simple examples just to see what's going on here. Okay, so in A we have log 8 plus log 2. There's no base indicated, so it's implied that it's base 10. So here we have 2 logs that are being added together. They have the same base, and so we can simplify this by multiplying the value. So 8 times 2 is 16. Right, so when we're simplifying, we're trying to make many terms into one term, if possible. Here we have log base 4 of 15, and the textbook says divide, but this is minus definitely log 4 or base 4 of 5. Okay, so here we have 2 logs that have the same base, and we're subtracting them. So using the subtraction rule, when we are subtracting logs with the same base, we can divide the values. So base 4, this will be 15 over 5, which can be further simplified into log base 4 of 3. Right, and the final one, we have 2 log 3 value 4 plus 5 log 3 2. Now the first thing we want to do is we have these 2 logs and they're being added, so we think we can just multiply the values. The important thing, the log law states that if we want to add logs of the same base, they cannot be a number in front. Okay, so if we have a look at the law, there is no number in front of this log, right? However, what we can do is, reversing the power rule, we can push these coefficients as exponents, and so we can have log base 3 of 4 squared plus log base 3 of 2 to the power of 5. Right, now we have logs with the same base, and we can multiply the values. So this will be log base 3 of 16 times 2 to the power of 5, and we can get log base 3 of 512. Okay, moving on to another type of question that we can be asked. So here we are given that log base 5 of p is equal to x, and log base 5 of q is equal to y, and we want to express all of these in terms of x and y. And so what we need to do is we need to convert all the logs into something that either has log base 5p or log base 5q. So we can change that into x and y. So the first one, if we have a look, we have log base 5 of p. So immediately we know that this can be x, all right? And here we have log base 5 of q cubed, right? So this is not what is equal to y, but if we move this 3 down to the front using the power rule, we'll get log base 5p plus 3 log base 5q. Now this resembles y, this resembles x, and so we get x plus 3y. All right, the next one we have log base 5 of p squared. So we can see again, here's a simple power rule, and here we have log base 5 of square root q. Right? So the first thing we need to do is we need to, well, we can bring the exponent down as a coefficient, so log base 5p. And what we need to do here is we need to change this square root q into index notation. So this will become log base 5, and square root of q can be written as q to the power of 1/2. Right, now we can use the power rule and bring that to the front. So we'll get 2 log base 5p minus 1/2 log base 5q. Right? And now once again, here's x, here's y, direct substitution, so we get 2x minus y over 2. Right, and onto the last one. Here we have log of base 5, and we have q over 5. So in this example here, all right, we need to change this, right, into something that resembles log 5q, right? So what we're going to do is we're going to use the subtraction rule, except we're going to split this up. This is a log that's being divided, so we're going to split it up. So we're going to write this as log base 5q, right, minus log base 5 of 5. So here we have our y, and while we don't have an x, this, right, log of a base to the same value is just equal to 1, and so this will just be y minus 1.